Welcome to another episode of the Fractal Mind podcast. In this episode, we're going to talk about the history of AI and how learning about AI history is your secret advantage to understanding this technology. Joining me today is my AI companion, Fractalist. It feels like AI is everywhere you turn these days. It's almost a cliche at this point, but I think something people might miss is that knowing how AI got here, its history, that could really be the secret advantage to understanding where it's going.
You're right. That's exactly what we're going to be looking at today. So this isn't going to be just another, surface level conversation about the latest AI trends. This is a deep dive into the history of AI.
Exactly. We're going way back. The goal is to give you, the listener, a kind of shortcut, to see the deeper patterns in how this technology has developed. We want you to come away being able to spot what works, what doesn't, and maybe even get a sense of where things might be headed next. It's almost like watching a time lapse of technologies unfolding.
That's a great way to put it. And, one thing that often gets overlooked is that a lot of people think AI is just this brand new thing, like it suddenly appeared with, say, ChatGPT or self-driving cars.
Yeah, that's so not true. AI has this incredibly long and fascinating history, and it's go way, way back. Today, we're going to travel back in time. We're going to explore those very early ideas about what artificial intelligence could even be.
So I guess the first question for us as we get started on this journey is, where do we begin? Do we start with those early philosophical ideas, those foundational concepts, or should we jump right into the 1950s when AI kind of became a distinct field of study?
Here's a great question. And even though the formal field that we know it came later, I actually think those early philosophical ideas are really important for context. I mean, they set the stage in a lot of ways. So maybe that's where we should start.
Okay, sounds good. It really is amazing to think that the very concept of artificial intelligence existed long before we even had computers. Like, think about those stories of automatons in ancient Greece,
Uh huh.
in mythology, or those mechanical beings described in Chinese folklore. It tells you something about this deep fascination humans have always had with the idea of creating intelligence.
It really does. And when you look at some of the foundational contributions of philosophers, it's actually kind of striking. Take Aristotle, for instance, his work on logic, this whole idea of reasoning based on rules, that's like a core element of what would later become known as symbolic AI.
Right, and it's pretty amazing that these ideas from so long ago would end up providing the framework for a very specific approach to AI. So symbolic AI, at its heart, is all about reasoning by following a set of rules.
Yeah.
Definitely want to unpack that concept a bit more later on.
Yeah, we'll definitely come back to that. And then you have Rene Descartes. Now, his idea that living beings, and he even included humans in this, his idea that they were basically mechanical rule following entities is actually pretty similar to some of those early AI systems that were based on rules. Like they tried to mimic intelligence, but they were just following these predetermined steps. There wasn't any real thought there.
And this is really important for understanding AI's development because it kind of foreshadowed this idea that you could have systems that perform tasks that seem intelligent, even if they're just operating based on these mechanisms that we've programmed into them.
Hmm.
And it's interesting how these philosophical debates from centuries ago are still relevant to AI research today.
For sure. And we can't forget Leibniz, his vision of a machine that could manipulate symbols and perform calculation. That was a crucial step. I mean, that really foreshadowed the development of modern computing as we know it. And as we'll see, it was really central concept in early AI as well.
It's like these thinkers were imagining how to actually mechanize intelligence.
Yeah,
They weren't just asking what is intelligence, they were asking how can we build something that has it.
exactly. So you have these ancient myths and then these philosophical inquiries. And all of this is setting the stage for this really pivotal moment in the mid 20th century. So let's fast forward. Let's go to the 1950s.
All right, let's do it. The The 1950s are really where things start to take off.
Definitely. Okay, first stop, 1950. We have Alan Turing and his paper Computing Machinery and Intelligence. In this paper, he takes on these fundamental questions. Can machines think? And this is where he proposes the famous Turing test.
Okay, the Turing test. This is a really key concept for anyone interested in AI. Instead of getting bogged down in this philosophical question of what thinking actually means, Turing kind of sidesteps that whole thing and asks a different question. Can a machine convince us that it's thinking? And that's a really clever way to look at it, I think.
Right. So the big idea of the Turing test is that you have a human evaluator and they are having a conversation, but they don't know if they are talking to another human or a machine. It's all done through text, okay?
I'm following you.
And the evaluator job is to figure out who is whose based only on the response they get. If the machine can fool the evaluator, if they can't tell the difference, then the machine passes the test.
It makes you wonder, though, does passing the Turing test actually mean the machine is intelligent? Or is it just really, really good at imitating human conversation? I mean, that's a debate that's still going on today, and it really gets at the heart of what intelligence is, whether it's human or artificial.
Totally. Okay, now let's move on to another super important event, the Dartmouth Conference in 1956. This is widely considered to be the official birth of AI as a field of research.
Yeah, the Dartmouth Conference. This was a huge moment in the history of AI. It brought together some of the most brilliant minds in the field at the time.
Oh yeah, it was like a who is who of early AI. Yeah, you had John McCarthy, Marvin Minsky, Nathaniel Rochester, Claude Shannon, and all these pioneers, all in the same room. And they was grappling with these really big questions. Could we make computer things?
That's such a simple question, but it's so profound. And it launched a whole field of research.
It really did. And you know what? It was at this conference that the term artificial intelligence was actually coined. Yeah, like that's where the name came from.
Wow, I didn't realize that. So they actually named the field at that meeting. But what did they mean when they talked about thinking computers back then? What kind of capabilities were they imagining?
Their vision was actually pretty broad. They were thinking about machines that could learn from experience, machine that could reason through problems, machine that could understand language and use it to communicate, machine that could adapt to new situations. Basically, they want a machine that could do all the things that we think of as human intelligence.
That's a pretty ambitious vision,
Yeah,
especially when you consider the computers they had back then. I mean, those early computers were mostly used for things like arithmetic, crunching numbers, data processing, solving very specific types of problems.
that's a great point. It's kind of like the difference between having a really fancy word processor that can manipulate text but doesn't actually understand what the words mean versus something that can actually comprehend the context.
That's a perfect analogy. So how did they start to approach this vision? What were some of the first steps they took?
One of the early approaches focused on problem solving. The idea was that you could break a lot of problems down into these logical steps, like games of chess, for instance.
I see. So they were trying to apply this kind of structured, logical thinking to things that we normally think of as requiring human intelligence.
Exactly. So imagine one of those early chess programs. It would analyze all the possible moves based on these pre-programmed strategies, and then it would assign a value to each board position, and the computer would just pick the move that led to the best possible value according to its program.
So it wasn't really thinking like a human chess player would. It was more like it was systematically evaluating all the options based on these rules that it had been given.
Exactly. And another area that they explored was adaptive and creative thinking. The idea was that maybe human thought itself is basically a process of manipulating symbols, like words or numbers according to specific rules. And so they thought if they can figure out these rules, then maybe we can get AI system to reason like human do.
Wow, that's a pretty bold idea, trying to reverse engineer the human mind like that.
It was. And the Dartmouth Conference really brought all these ideas together. So to recap, How can machine learn? How can they process language? How can they solve problems like humans? These was the big questions that shaped AI research for years to come. And like we were talking about earlier, these questions led to different approaches to actually achieving artificial intelligence. And I'm really interested in symbolic AI. We touched on that a little bit before. How did that approach tackle those big questions about machine intelligence?
Right. So think of these different approaches like different paths that researchers were exploring. Symbolic AI, sometimes called GOFAI, which stands for Good Old-Fashioned Artificial Intelligence, that became the main approach in the years right after the Dartmouth Conference.
Okay, so what was the basic idea behind symbolic AI? What was the thinking there?
Well, the core idea was that you could replicate intelligence by having computers manipulate symbols, things like words or numbers, but they would do it based on a set of logical rules. It's like giving the computer this really detailed rule book on how to think and reason.
So instead of trying to get the machine to learn from data, they was basically programming it with knowledge and rule?
Exactly. And a great example of this in action was the development of expert systems. One of the early ones was called MYCIN, and it was designed to help diagnose bacterial infections.
Oh wow, so MYCIN was like an early attempt to put the doctor expertise into a computer system? How did that actually work?
Well, MYCIN was designed to imitate how a human doctor would make a diagnosis. So it used a bunch of if-then rules, based on things like the patient's symptoms and their medical history. And then by applying these rules, the system could come up with a diagnosis and even suggest treatments. It was like a digital doctor that was following a set of steps based on expert knowledge.
That's really cool. It's like they were trying to codify all that human expertise into a set of logical rule. But I imagine it must have been incredibly hard to build something like that. Like you have to come up with all those rules and think of every possible situation, right?
Yeah, that was definitely one of the big limitations of symbolic AI. The amount of work it took to build those systems and the expertise it required, especially for complex problems, that was a huge challenge. And it really gets at this idea that trying to define the real world with neat and tidy rules is really difficult. And that eventually leads to a shift towards using data instead.
Right, because the world is messy and complicated. And so what about situation where the information wasn't complete or there was a lot of uncertainty? How did symbolic AI deal with that?
That was another big problem. Symbolic AI really struggled with uncertainty. In the real world, a lot of problems don't have clear-cut answers. There's ambiguity, missing information, and it was really hard to come up with rules that could handle all of that.
So it sounds like symbolic AI was better suited for problems that had very well defined rules and not a lot of ambiguity.
Yeah, that's right. It also had trouble scaling up to handle really large amounts of knowledge. And maybe most importantly, it didn't really have a good way to learn from data the way later approaches would.
So if it had all these limitations, why was symbolic AI so important in the early days? What were some of its strengths?
Well, despite its weaknesses, symbolic AI was actually pretty good at certain kinds of tasks, especially tasks that involved logic and well-defined rules, like solving math problems or playing games like chess. And because everything was based on these explicit rules, you could often understand exactly how the system arrived at its conclusions. That was a big advantage, especially compared to some of the later AI methods that can be kind of like black boxes, where you don't know exactly what's going on inside.
That makes sense. But as the field progressed and they started to tackle more complex problems, those limitations would have become more apparent. And I think that what led to the rise of connectionism, right?
Exactly. Connectionism was a completely different approach. It was inspired by the way the human brain works. So instead of manipulating symbols according to rules, it focused on building networks of these artificial neurons that could learn from data. And the big idea here was that you didn't have to program everything in. You could let the system learn on its own, kind of like how we learn from experience.
So it was less about programming and more about letting the system figure things out through experience.
Right. And these ideas actually go back to the 1940s with early work on neural networks. But it was the development of the backpropagation algorithm in the 1980s that really made connectionism take off. So think of backpropagation as the learning mechanism that allows these neural networks to actually get better over time. It's like when a student makes a mistake and then goes back and corrects it. This algorithm allowed researchers to train these multi-layered neural networks by adjusting the connections between the neurons based on the errors they made. And this was a big deal because it paved the way for what we now call deep learning.
And deep learning is basically training neural networks with lots and lots of layers, which allows them to learn these really complex patterns and data. And that's what's behind a lot of the recent advancement in things like image recognitions, speech recognitions, natural language processing, and all that stuff.
That's right. And while we won't get into the details of deep learning here, it's important to see how it came out of connectionism and how it's really pushed AI forward. So compared to symbolic AI, what would you say are the main pros and cons of connectionism for someone who's trying to understand the big picture?
Well, one of the big advantage of neural networks is that they're really, really good at recognizing patterns in large data sets. They can pick up on really subtle relationships that would be super hard to describe with rules. And they also tend to be more robust when the data is messy or incomplete.
That makes sense. That's really important for real-world problems where you don't always have perfect data. But what about the downsides?
One of the big challenges is what called the black box problem. With these really complex neural networks, it can be hard to understand why they make the decision they do. Their reasoning process isn't always transparent, and training these models often require huge amounts of data and a lot of computing power. It's not something you can do on your laptop. You often need specialized hardware for that. And then there's the issue of overfitting, where the model learns the training data so well that it doesn't generalize well to new data. It's kind of like memorizing the answers instead of actually understanding the concepts.
It sounds like both approaches have their strengths and weaknesses. Symbolic AI was more transparent, but struggled with complexity and uncertainty. And connectionism is great at pattern recognition, but can be hard to understand and needs a lot of data. So have researchers tried to combine these two approaches?
Yeah, absolutely. In fact, there's a growing trend towards combining these different approaches. Neurosymbolic AI is one example of this, where they're trying to merge the rule-based reasoning of symbolic AI with the learning capabilities of connectionism. The idea is to get the best of both worlds, if you will.
That makes a lot of sense. It's like a hybrid approach. But looking back at the history, it hasn't always been smooth sailing, right? There were these periods of slowdown and disillusionment.
Yeah, you're right. There have definitely been ups and downs in the history of AI. There was these periods called AI winters, where progress slowed down, funding dried up, and there was a general sense of disappointment.
What caused these AI winters? What happened?
The first one happened in the 1970s, and it was mainly because a lot of those early promises of AI weren't panning out. For example, machine translation turned out to be way harder than people initially thought. So there was this sense of like, okay, AI isn't living up to the hype, and that led to funding cuts and slowdown in research.
So it was a case of overpromising and underdelivering. What about the second AI winter?
The second one happened in the late 1980s and early 1990s, and that one was partly due to the collapse of this market for specialized AI hardware called list machines. They was computer that was specifically designed to run AI programs, and when those machines kind of went out of fashion, it had a big impact on the field. Also, expert system, which had been really hyped up, weren't as successful in practice as people had hoped. So there was another wave of disillusionment.
It sounds like these AI winters were kind of like reality checks. They forced the field to become more realistic about what it could achieve and to focus on practical results. But the field eventually bounced back, right?
It did. Even during those AI winters, there were researchers who kept working on things like machine learning, neural networks, evolutionary computation. It was kind of under the radar, but it was happening. And then in the late 1990s and early 2000s, people started to find practical application for AI and things like data mining and recommendation system. and that helped to rekindle interest and investment in the field. And then, of course, you have the current AI boom, which is largely driven by big data, powerful GPUs, and advances in deep learning.
Right, and now we have these large language models, or
Yeah.
LLMs, things like GPT and other transformer models. These have really changed the game in terms of what AI can do. They can generate really human-like text, translate languages, write code, even do some pretty complex reasoning. And it's interesting because these models, they're based on deep learning, but they also seem to exhibit some aspects of symbolic reasoning in the way they handle language. What do you think about LLMs and how they fit into this whole history of AI?
That's a great question. LLMs are a huge leap forward. In terms of how we can process and generate language, they are trained on these massive data set and they can produce text that's really fluent and coherent. It's something that we couldn't have imagined just a few years ago. And we already seeing the impact in all sort of areas from improving how we interact with computers to helping with software development to creating new kinds of content even to transforming education.
And while LLMs offer all these amazing possibilities, they also raise some important challenges, like the potential for job displacement is a big one. As these models get better and better, there's a real concern that they could automate a lot of tasks that humans currently do, especially jobs that involve a lot of repetitive or text-based work.
Yeah, no doubt. That's the big question that a lot of people are thinking about. Will these models replace jobs or will they transform jobs and create new opportunities? I mean, throughout history, technological advancement have always led to new kinds of jobs. It's just a matter of figuring out what those new jobs will be and how we can adapt to this changing landscape.
I think it's important to remember that AI, including LLMs, isn't about replacing humans. It's about giving us new tools and new capabilities. There's this quote that I really like: AI won't replace you, but someone who knows AI will. I think that really captures the essence of it. It's a challenge for us to learn and grow and to figure out how to use these tools effectively.
I like that perspective. It's about embracing the change and figuring out how to use these new technologies to our advantage. And this whole conversation really highlights why it's so important to understand the history of AI. It gives you this context, this framework for understanding where we are today and where we might be going next.
Absolutely. So for the listener, understanding the different schools of thought in AI, like symbolic AI and connectionism, that gives you a way to understand the different approaches to building intelligent systems and how they've evolved. It helps you see why certain methods were popular at different times, what their strengths and weaknesses were, and how they all fit together.
And when you have that historical perspective, you can start to see the connection between what's happening today and what happened in the past. It gives you a much deeper understanding of the current AI landscape.
Exactly. Plus, if you want to learn more about AI, you'll find that a lot of the more advanced discussions kind of assume that you already know this stuff. So having this foundation will make it a lot easier to understand those more complex topics. So, to sum it all up, AI has this rich and complex history, and it's still evolving. There have been different phases, different approaches, different challenges along the way.
And through it all, there's been this incredible amount of human ingenuity and perseverance. And even when things slowed down, even when there were setbacks, people kept pushing forward.
In this conversation, this dives into the history of AI. It's really just the beginning. There's so much more to explore. We could talk about specific algorithms, the ethical implications of AI, all sorts of things. So if you're interested in learning more, we'll definitely be diving into more of these topics in future episodes.
Absolutely. And with that, I want to thank you for joining me on this deep dive. It's been a great conversation.
The pleasure was all mine.
And to all our listeners, thank you for tuning in. We'll catch you next time. And in the meantime, stay curious.